this expression, which you can read aloud as 3 to the 4th power. Right, 3 to the 4th is 3 times 3 times 3 times 3, or 81. Now let's quickly introduce the names for the terms in this expression. This whole expression, 3 to the 4th, is known as a power. This number up here, which says how many times you're multiplying, is called an exponent. And the number down here that's being multiplied by itself is called the base. So go ahead and quickly identify the base in this power and the exponent in this power. Exactly. The base in this power is 5, and the exponent in this power is 7. Now let's look at a real-world example. Suppose you're looking at bacteria under a microscope. In a relatively short amount of time, a few bacteria can become thousands or even millions. So suppose you start with a single bacterium at noon, and it doubles or splits into 2 every hour. So at 1 p.m. you have 2 bacteria. And by 2 p.m., both of these have divided into 2 more, so we have a total of 4 bacteria. By 3 p.m., they've doubled again, so now we have 8 bacteria. And they keep doubling every hour. Here's 5 p.m., 6 p.m., and 7 p.m. So how many bacteria do you have at 7 p.m. after they've been dividing for 7 hours? Well, let's look at 1 hour at a time. We started with 1 bacterium, so after 1 hour, there are 2. If we wait another hour, each of these divides, so we now have twice as many, which is 2 times 2, or 2 squared. After 3 hours, each one divides again, so we have 2 times 2 times 2, or 2 cubed. And after 4 hours, we have 2 to the 4th. So how many bacteria will there be after 7 hours? Be sure to enter the exact number.
After 7 hours, we'll have 2 to the 7th bacteria. How many is that? We can evaluate 2 to the 7th using our calculator. 2 raised to the 7th power is 128. So after 7 hours, there'll be 128 bacteria.
Precisely, after 7 hours, there are 2 to the 7th, or 128, bacteria. That may not sound like too many, but after just 1 day, or 24 hours, there are 2 to the 24th bacteria, which is more than 16 million. So doubling every hour may not sound that fast, but before you know it, you have millions of bacteria on your hands. Next, let's look at powers of negative numbers like -2 to the 3rd power. That means we're multiplying -2 by -2 by -2. Multiplying the first two gives us +4 times -2, which equals -8. So -2 to the 3rd power equals -8. Next, try evaluating a few more powers of negative numbers.
Let's start with -7 squared. That's equal to -7 times -7. 7 times 7 is 49, and those negative signs will cancel out, so -7 squared is +49. Next, let's try negative 5 cubed. Negative 5 cubed is the same thing as negative 5 times negative 5 times negative 5. Negative 5 times negative 5 is positive 25. Those negative signs cancel out, so now we have 25 times negative 5. 5 times 25 is 125, and that negative sign will stay. So negative 5 cubed is negative 125. Why don't you try the last two? Negative 3 to the fourth is negative 3 times negative 3 times negative 3 times negative 3. Now there's an even number of negative signs there, so they'll all cancel out, and negative 3 to the fourth will be the same thing as 3 to the fourth, which we already know is 81. Negative 2 to the fifth is negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Now there are 5 2's there, and 2 to the fifth is 32. There are also 5 negative signs. 4 of them will cancel out, and we'll be left with one odd negative sign. So negative 2 to the fifth is negative 32.
Nicely done. So here are the answers you found. You might have noticed a pattern. Raising a negative number to even powers, like 2 and 4, gives you a positive result, while raising to odd powers, like 3 and 5, gives you a negative result. Next, see what happens when you raise 0 to different powers and when you raise 1 to different powers.
If we raise 0 to the second power, that's 0 times 0, which is just 0. What happens when we raise 0 to the ninth power? 1 to the third power is 1 times 1 times 1. And 1 times 1 is 1, and if we multiply that by 1, we still have 1. So 1 to the third power is 1. Why don't you try the last two?
Right, so 0 raised to any power will always give you 0, and 1 raised to any power will always give you 1.